Let's take a look at a review of the last few sections where we have entered data into Desmos to get scatterplots, looked at residuals and lines of best fit. I don't know if you guys have ever seen this televised, but each year on the 4th of July, Nathan's Famous Hot Dogs holds a hot dog eating contest, and below is the data for the winning numbers of hot dogs for both men and women for the last 10 years. Kind of fits into that competitive eating, which never looks too healthy to me, but apparently some people are into it and actually train for it. So year one, I guess that would be the original 2010, and then actually year zero would be 2010, so let's see. Year one would be 2011, then year two would be 2012, and year three would be 2013, and so on and so forth until year 10 was 2020. Part A says use Desmos to create a scatter plot of the men's hot dog eating contest, calculate the equation for the line of best fit, show the residuals for the data, paste the graph and table and calculations below. All right, so actually let's get the right application up here. Let's go to Desmos. We have done this a few times now. And so we're going to enter in the table of data for the men first here. A little bit later on, you'll do the women's data. So remember, we add a table up here, and our X1 column will be those years. So 1, 2, and then notice it will just start filling in if we're using the pattern that's there all the way through 10. And then we'll go to Y sub 1 and we'll put in the number of hot dogs. So 62 in that first year, 68, 69, 61, 62, 70, 72, 74, 71, 75. And looks like we have a decent window here that we are looking at. So actually can see the scale and see kind of how the graph looks over here. And then we're going to do a line of best fit for this data. So we're going to click down here. We're going to do Y sub 1. Remember, we hit Y1. And then we use the little tilde symbol. So we're doing Y equals MX plus B, remember, but we're putting in the right symbols. So MX1 plus B. All right, so then we've got our data, and then we're also going to be plotting the residuals. So we've got our scatter plot, we've got our line of best fit. Notice there's a slope and a y-intercept for that. And then to plot the residuals, remember the residuals are the distance between the red scatter plot points and the line. So if you just hit the plot, where it says plot there, under your y1 is equal to mx plus b, and then it will graph the residuals and give them to us in the table. So I'm just going to get a little better view here so that we can actually see the residuals. Notice the residuals are graphed down at the bottom in green, and we'll talk about that in just a moment. But let's take a scatter plot screenshot of what we've got here. Drop that into our notes or our review here. And we're going to blow this up a little bit. All right, now I'm going to make a few notes on here. I'd like you to as well, if possible. So let's just look at our headings here. So basically we have the years and the hot dogs that are our scatter plot. So this is our scatter plot info right here, in which we have years and we have hot dogs And so over here on our graph, this is our scatter plot of that information. Okay, and let's also just identify. So the y-axis is hot dogs eaten, and the x-axis down here is years since 2010. So we've got that information. And then we have some residuals. So over here in this column are our residuals. You see some of them are negative and some of them are positive because it's basically just the distance between the point and the line. So if it's close to the line, then you have a very small residual. And so it's just this distance. Notice I'm just going to kind of record these distances because down below here with the green points, they're all showing us those same residuals. Notice that point right there, and then this point is represented down here because that's just graphing how far it is away from 0. So it's just kind of another way of representing the vertical line here. So each one of these, so here's the residual, here's that residual down here, just being graphed as the distance from 0. There's that residual, and that's represented down below here. So I sometimes like to draw these little lines in between the point and the line to just show that's the distance. That's what a residual means. It's essentially the distance between the point and the line. And each one of those distances is shown right over here in the table, where the negatives, remember, mean that the point is below the line. So for instance, this one right here, that's going to be that residual right there because it's about negative 5.5. It's 5.5 units below the line. Notice the next one, similar, is 5.8 units below the line. So you can see how those are shown in there as well. All right, so those are the residuals. I'll just actually write that down here because that's what that graph is of the residuals. And let's see, what else do we have here in our information? Got a couple other pieces of information. We have the slope of our line of best fit is about 1.24, and we have our y-intercept of our line, which is about 61.6, and you can kind of see that right here, is that y-intercept is about 61.6 for our line. All right, so that information is also given for us.